Hey guys, I'm a verified educator at Unacademy, and along with that, I'm also teaching live at Unacademy Plus. To access my live classes, you can take Unacademy Plus subscription. Now, Unacademy Plus offers some interesting features apart from live classes, which include detailed and complete explanation of a particular course. Then there you have problem discussion for self-evaluation. You can also watch recorded version of the class in case if you miss out any live session. You have regular doubt clearing sessions for doubt clearing and to clarify all your problems. You also get access to the WhatsApp group to clear and discuss problem among the other plus students. Now, if you have found these features interesting and want to join Unacademy Plus, I'll recommend you to use my referral code that is N_Huda to get 10% discount on the subscription fee. Now that's all about Unacademy Plus. Let's continue with our video. We'll be talking about this question over here, and it was asked for 4 marks in your CSIR June 2019 exam. Okay, and it was asked for 4 marks from the organic chemistry portion, and it says that structure A and B in the following reaction are. Okay, so this is the molecule given to you, and they have, like, it's given that they have given a group over here, that is R, substituent R, and they have just changed the substituent. So you have phenyl as the phenyl group as the substituent over here, and you have like CO2 ET as the phenyl as the R group over here. Okay, so you have to tell what is A and what is B. Okay, so that's what you have to tell. So this particular question was asked from rearrangement portion, like from the organic chemistry. You might have studied a lot of rearrangements. From there, one of them was asked directly in this particular question, and that rearrangement is called as Dienone-Phenol rearrangement. Okay, so Dienone-Phenol rearrangement. So before solving this particular question, I'll just explain you that what it is Dienone-Phenol rearrangement. Okay, and after that we'll come back to this question to solve. As the name suggests, Dienone-Phenol rearrangement, that means you will be having two parts of this enone part, right? Enone part means alpha beta unsaturated ketone. So that will be like that is di means that will be of two parts, and that will get converted into phenol by through the rearrangement. So that is what happens in this Dienone-Phenol rearrangement. If I just show you with the example, so if you have, let's say this is your dienone, okay, and let's say we have two groups over here, and in the presence of some acid, what will happen, that it will get converted. So it's a dienone, right? You can see that this is enone, like in and on the right side, sorry, on the left side, and similarly on the right hand side. So that's why it is called as dienone. So in the presence of acid, this will get converted into a benzene ring, a phenol ring basically, and the rearrangement of these two groups will take place. Alright, so this is what Dienone-Phenol rearrangement is. The driving force for this particular reaction is aromatic, the formation of aromatic ring. Okay, so formation of aromatic ring is the driving force for this particular reaction. Now let's look upon to the mechanism, that what is happening. So I'll just show you that what will happen in this particular reaction first of all. So in the first step, if you look, so since you have taken acid, so you have dienone. So let's say we have R and R over here, and this is R double bond O. Okay, so in the presence of acid, what will happen, that this proton will be abstracted by this oxygen, and you will have something like this in the next step. So this is R, this is R, we have the whole molecule like this. Oxygen will gain a positive charge, hydrogen will be attached over here. Now since oxygen is having a positive charge, it's not a stable thing to do, so that means rearrangement will be done, or these pi bonds will shift towards this oxygen. This bond will shift over here, and then next step you will get a carbocation formed at this particular place, because that from that place your electrons have shifted, right? So you'll be having OH formed over here, a pi bond formed over here, a carbocation formed, and two R groups over here. Now as you can see in this step, that this particular thing is a 2-degree carbocation, right? Carbocation. So what can happen now, that this particular R group, it can migrate from this position to this position, and after this migration, a 3-degree carbocation will be formed, which will be more stable. So formation of more stable carbocation is the driving force for this particular step. So this thing will shift or rearrange from here. So 1 2 shift is happening in this step, and the next product which you will get will be a carbocation formed. Okay, so we'll be having R over here, this, and we'll be having OH. Now the carbocation will be formed at this particular place. Now this carbocation is a 3-degree carbocation, right? So it's a 3-degree carbocation and it's more stable. Now what will happen in the last step, just to maintain the aromaticity, since you will be having hydrogen at this particular carbon, so this hydrogen, like this particular hydrogen, since we have taken hydrogen from the acid, right? So that hydrogen we have to give it back. So in this step this hydrogen will liberate and this bond will shift over here in order to give you the product. So this is the mechanism of this particular whole reaction. So as you can see that the rearrangement is happening in this particular step, and the rearrangement is happening just to make a more stable carbocation. And like from the starting it was a non-aromatic compound and now you are getting aromatic compound. So that's the driving force of this particular reaction. Now this was pretty simple if we were having these two R groups same. Now let's say if we have two different R groups, okay, let's say instead of this R, like one is methyl group and other one is ethyl group. So what will happen then? Okay, so that's what we are going to discuss now. So that will be decided through the migratory aptitude. Okay, so that particular thing you will decide through the migratory aptitude. So let me just discuss a little bit about migratory aptitude. I hope you all know about it, but I'll just discuss the basics of it. So migratory aptitude decides, or it tells you, it helps you to find out that if you have two groups or two substituent to migrate, which one will migrate first, okay, or which one will migrate basically. So I'll just write down an order which is followed in this Dienone-Phenol rearrangement. This order which I'm going to write is not followed everywhere in a strict manner, but yeah, generally this is the order of migratory aptitude of rearrangement, although you might see some examples where this order is not followed. Actually the order has to be decided based upon the what kind of rearrangement is being done or what kind of migration is basically being done. But for Dienone-Phenol rearrangement and for pinochle rearrangement, for all these kind of reactions, whatever migratory aptitude I'm going to write, that is followed generally. Okay, so in this particular migratory aptitude, we'll start from this phenyl carbon ion. Okay, so if you have pH minus, it will get migrated first, then you will be having 3-degree carbon ion. That means if you have CH3 CH3 kind of group, so this particular whole group will migrate next. After that, if you have CH3 CH3, so this group will be migrated next, and then comes your CH3 CH, that means 1-degree group, and the least one is your for the methyl group. Okay, so this is the order of migratory aptitude. What is the trend of this migratory aptitude is that more electron rich group migrates first. Okay, migrates first. Now as you can see, phenyl ring is already, like, it's more electron rich. Then comes your 3-degree, then comes your 2-degree. So basically this is nothing but a 3-degree carbon, and this is 2-degree carbon, and this is 1-degree, and this is methyl carbon. So this is the order of migratory aptitude. So by now I have all explained about Dienone-Phenol rearrangement. Now we'll get back to the question, and with the help of that question, we'll try to see that how we can do that question based upon this Dienone-Phenol rearrangement. Alright, so to answer this particular question, I'll go with A first of all. So in reaction A, what will happen? Okay, so let me just, okay, so for A, what will happen? So we have this group, and we have in A, R is nothing but the phenyl ring. So this is, this is methyl, okay, and this is phenyl. So this bond I'm just going to write down Me just to make sure that I don't miss out anything. Okay, double bond. So I have just written methyl because it's methyl group over here. Okay, now in the first step, again the same thing, CF3 COOH is taken. So now what will happen? Protonation of this ring, protonation of this ketone, like oxygen basically, carbonyl oxygen, then methyl, then comes your phenyl ring. Now over here you have OH with a positive charge. All right, now you will be having again the same mechanism will be done like that. So I'm just doing through the mechanism just to make sure that I don't miss out anything. Okay, uh, sorry, we were having double bond also, right? Yeah, so this bond will shift over here. So in the next step we will be having, okay, so we will be having methyl, we are having pH, we have double bond, we have double bond here, we have OH at this particular place, and a carbocation. Now here is the deciding factor that what and which group will migrate. So as I told you, in the migratory aptitude we have seen that phenyl group has a more migrating aptitude than methyl group. Okay, so pH has a more migratory aptitude than the methyl part, so that's why this particular like phenyl group will migrate at this position. And fine, so what will happen in the next step then? Formation of a carbocation. Okay, so next a more stable carbocation will be formed, because this was a 2-degree carbocation. So you have methyl over here, you have pH over here, so OH and a carbocation at this particular place. Now again the last step was what? We were having proton over here, so this proton will be given back to the acid and this bond will shift back to give you the final product, that is nothing but methyl over here, and we have pH. Okay, and this is the final product. This was the product when you got when you did for A part. Okay, so the product formed is of 4 methyl 3 phenyl phenol. Okay, so that is what is formed in this particular step by reaction number A. Now let's look upon the B part. Okay, so what will happen for the B part of the reaction? Now talking about reaction B, so over here also like similar thing will happen at the place of R. We were having like ethoxy carbonyl group over here. So ethoxy carbonyl group is present in the place of, like earlier in the option A, like in the reaction A we were having phenyl group at this place, right? Now the first step will be same, proton abstraction by this oxygen, then rearrangement in this way that you have a double bond in this ring and a carbocation formed at this like a uh, like a carbocation formed in the ring, right? So this was happening in the previous reaction also, so I have just written this up to here. Now the main thing starts from here. So now two things can happen over here. Either this, because in the migratory aptitude we have studied about methyl, phenyl and all the groups, we have not studied about this ethoxy carbonyl group, right? So what will happen now, that we have to see the possibilities. So what is the first possibility? That this particular COOET, this groups migrates. Okay, so if this groups migrates, so COOET migrates. Okay, so let's say this migrates. So if it migrates, it will go to this particular place, and what will happen, that you will have something like this. Okay, so you will be having methyl group over here, carbocation formed over here. Now you have COOET placed at this particular place. Rest of the things will remain as it is, your OH over here. And in the last step, what will happen, that this hydrogen, will be given to the acid and this bond will shift over here. So the final product will be nothing uh, but methyl at the para position of this phenolic OH, and COOET formed at the meta position. Okay, so this is what you will get as the final product. Now if you go to the other possibility, if you just look upon to the other possibility, so the other possibility is that your methyl group migrates. Okay, so if your methyl group migrates, let's say methyl migrates. Okay, so what will happen if methyl migrates? So now the next thing which you will get will be something like this. So you will be having COOET over here, a carbocation over here, methyl group over here, and rest of the bonds at their own respective places which present over here. Now this particular carbocation is less stable carbocation, right? This carbocation is less stable because of this, because of the carbonyl group present at this just position. If I just like show you, so this is how it will look like. So C double bond O OET. So due to that, due to the presence of this particular group, this carbocation becomes less stable. Whereas over here in this step, if you just look upon to the carbocation, this is more stable carbocation, right? So more stable carbocation because this carbocation is being stabilized by the methyl group or the CH3 group, right? So that is stabilizing the neighboring like carbocation, and whereas this COOET is destabilizing this carbocation. So the final product will be formed from the more stable carbocation, and that's why this particular thing will be your, like this one will be your major product, or this will be the thing which will be formed. So that means what will be the answer for that? So if you'll just look upon to the options over here, so in option A, both of the products of reaction A and reaction B are correctly shown over here. In reaction A, we were having phenyl group at the meta position, and in reaction B, we were having like ethoxy carbonyl group at the meta position. So this is going to be your correct option over here. Okay, so this is how this reaction was asked, Dienone-Phenol Rearrangement, and this is how it has to be answered. Whole mechanism and everything I have explained you in this video. I hope this video was clear to you. I hope you guys understood how to solve this question, and in future if the reaction will be asked based upon similar concept, you guys will be able to do that, right? So thank you so much for watching, guys. And one more thing, that if you are new to this channel, do subscribe to the channel. If you like this video, give it a like, and thank you so much from my side. Have a great day. Bye bye.